Pop quiz time. What is DECT NR+? If you said the world's first non-cellular 5G technology standard, you get a gold star for today. If maybe just a virtual gold star. But why would we need a non-cellular 5G technology standard? What kind of applications would be a good fit for a low-cost private 5G network? I'm glad you asked, because this is exactly what we're talking about today and how you can get started using DECT NR Plus with Nordic Semiconductor's NRF91 System in Package family. Hi, I'm Amelia Dalton, host of Chalk Talk. In the ever-expanding IoT market, there is a growing need for private, low-cost networks. In this episode of Chalk Talk, Heidi Sollie from Nordic Semiconductor and I explore the what, where, and how of DECT NR+, the world's first non-cellular 5G technology standard. We investigate how this self-healing, decentralized, autonomous mesh network can help solve a variety of IoT connectivity issues, and how Nordic is helping designers take advantage of DECT NR Plus with their NRF91 System in Package family. And before we get started, don't forget to click that link. There you can find even more information about this topic from Nordic Semiconductor. Hi, Heidi. Thank you so much for joining me.
Hi, thanks for having me.
Absolutely. Okay, so we're talking about how we can utilize DECT wireless technology for IoT connectivity today. But before we dig into the details, how did DECT technology come to be?
Yeah, so DECT NR Plus, or DECT 2020 New Radio, as one might also see it being referred to, comes from the DECT technology. That's Digital Enhanced Cordless Telecommunications, which was a standard that came around in the early 90s. It was initially primarily used for cordless telephones. The DECT technology is developed by ETSI, that's the European Telecommunications Standards Institute, but it was also adopted by many countries worldwide. And since the original standard came out in the 90s, there have been numerous iterations and developments on the technology. And so this newest kind of version of the standard, this DECT NR Plus, when they were working on it, the design objectives there was to create a wireless communication technology that could be deployed by anyone, operated by anybody, and used anywhere. It should be application agnostic, which means you can run any application protocol you want on top of it, making it easy to adopt for different use cases. So in 2020, the DECT 2020 New Radio Standard, or DECT NR Plus, as we also call it, is published. It defines a new physical interface, which has many more capabilities, some of which we're going to talk about a bit later. And this technology was then also approved as one of the 5G standards set by the ITUR, which has previously only included cellular technologies. As most people know, cellular technologies are networks where the network is distributed over land areas, usually called cells, and each cell is served by one transceiver, like a cell tower or a base station. And since NR Plus does not rely on the cellular network, it's actually the first and currently only standard approved as a 5G standard, which is non-cellular. We commonly refer to it as non-cellular 5G.
Okay, so Heidi, before we go much further, we should discuss 5G and the standards that come into play here.
Yeah, definitely. So to start from the beginning, I guess, the ITUR, or the radio communications sector of the International Telecommunications Union, they define these overall standards for the next generation of telecommunication. So networks, devices, services. And these come out every 10 years or so. So for example, the IMT 2000 document specified the requirements for 3G. And in 2015, they published the IMT 2020, which defines the technical requirements for the 5G standard. And then the standard organizations, 3GPP and ETSI, they developed the radio access technologies to meet these requirements. And in our case, ETSI developed this DECT NR Plus to meet some of the requirements of the IMT 2020. So the IMT 2020 defined three main application areas or groups of use cases that 5G technologies should service, which also comes along with a set of technical requirements for each category. And we can see all the categories here in this triangle. Enhanced mobile broadband, that's the one at the top. addresses things like video streaming, augmented reality, virtual reality, all being used over the cellular network. And this is essentially just a straightforward evolution of the mobile networks. It requires higher data rates, lower latency, and in general, just increased capacity on the mobile network. And this area of use case is addressed by the 5G new radio technology, which is the 5G technology currently being deployed by cellular providers soon, or some of you might already have started seeing it in your handheld devices. Your mobile phone might be using 5G. That's the kind of technology everyone thinks of when talking about 5G, is this area at the top. But then on the bottom left, we have massive machine type communication use cases. These are use cases that focus on connecting a massive number of low power constrained devices. And these use cases generally show up when we talk about IoT, Internet of Things, when individual devices want to connect directly to the cellular network and transmit very small amounts of data, like, for example, a temperature sensor transmitting the temperature, or a name tag on your pet transmitting its location. So here the focus is on supporting dense networks, and where the networks are very scalable, you can start with a small amount of nodes and scale up. And of course, low power consumption. And one of the specific requirements is that the network must be able to support up to 1 million nodes per square kilometer. And this is also the application area where the cellular IoT technologies, so LTE-M and narrowband IoT, they address these use cases. And then lastly, there is ultra reliable low latency communication. And this addresses use cases where failure is not an option, use cases that require, as the name says, ultra low latency and very high reliability. So things like self-driving factory vehicles, high-speed robots, critical infrastructure. So URLLC requires under 1 millisecond latency on the packet level and over 99.99% reliability on packet delivery. Essentially, you get the same kind of latency and reliability as a wired connection without the physical constraints of wires. And DECT NR Plus, or non-cellular 5G, fulfills the technical requirements and has been approved for both massive machine type communication and ultra reliable low latency communication.
So, Heidi, what does the topology of a DECT NR Plus network look like? What kind of elements are included in these kind of designs?
Each NR Plus node has a specific role. They can either be a sink. This is essentially just a gateway. It has an external connection to the rest of the internet, either via a cellular connection, a wired connection like Ethernet, doesn't really matter. All messages in the NR Plus network are ultimately routed up to the sink node. And networks can also have more than one sink node. Then we have relay nodes. These are nodes that have the capability to route messages to other nodes, as well as sending data itself. Lastly, we have leaf nodes, and they can only send data. And NR Plus supports 3 different topologies. We have point-to-point, star, and mesh topology. In point-to-point and star networks, at least one node has the role of the sink, and then all the rest of the nodes are leaf nodes, just transmitting data directly to the sink node. In the mesh topology, things get a bit more advanced. The mesh topology is technically what's called a partial mesh clustered tree topology. Partial mesh just means that not all the nodes are connected to each other like you would see in a full mesh. And the clustered tree topology means that the network is divided into individual clusters, and the clusters have this kind of star topology, but with branches. And in the NR Plus mesh topology, nodes can assign themselves roles based on the needs of the network, which gives this self-organizing and self-healing feature. So if a sink node fails in a network that has multiple sinks, nodes can automatically reroute to the nearest alternative sink. Each device decides the next hop or how to route the packet individually based on available routes towards the sink, which means the clusters are formed dynamically. This also means there is no single point of failure, as nodes will automatically reroute packets if a node fails. This self-organizing, self-healing topology is also very good in dense networks where congestion issues can be a problem. So the network can self-organize and optimize and avoid any kind of congestion issues that you would see in some other mesh topologies. So here we can see an example of an NR Plus mesh network topology that has 3 clusters and 1 sink node. Some of the relay nodes are routing messages to other clusters and extending the network. And then some of the relay nodes, the one all the way at the bottom, you can see that it has this capability, but it is not currently required by the network topology. So it's just acting as a leaf node, sending data up to the sink. Clusters can also use different channels within the specified operation frequency. So the relay nodes that are kind of in charge of each cluster can continuously scan the frequency channels for the one with least interference, and then instruct the other nodes in the cluster to change channels to optimize the interference avoidance, which is also very useful in dense networks where interference can be an issue.
So, Heidi, what kind of frequency bands are we talking about here?
Since NR Plus is a DECT technology, it has access to the classic DECT frequency band, which is 1.9 gigahertz. This is a relatively global frequency band. We can see this map here, which shows all the countries where the 1.9 gigahertz band is allocated to the DECT technology. And it is a relatively large area. The DECT band is license free, meaning users can avoid that cost that would sometimes come up in other technologies like cellular. This also allows for deploying one single product worldwide without the need for frequency planning. And since NR Plus is an IMT 2020 technology as well, it's not restricted to the DECT band. It can access other bands. And the standard itself supports multiple licensed and unlicensed bands from 450 megahertz and up to 6 gigahertz.
Okay, so when it comes to DECT NR Plus, what do you think my audience should keep in mind?
Some of the things we've already discussed. Here are 6 kind of unique things that I want to bring up about NR Plus. So first of all, it's a 5G standard. This opens the possibility for one standardized option instead of kind of many proprietary solutions. As for the network topologies, it supports point-to-point, star, and mesh topology. And the mesh topology specifically has this self-healing, self-organizing property that's very unique and very useful in a lot of IoT use cases. NR Plus also has access to the globally allocated 1.9 gigahertz frequency band, which is also very unique. It is intended for massive machine type communication, meaning it supports massive networks. The construction of the NR Plus IDs mean that a single NR Plus network can have 4 billion individual radio devices and 65,000 within radio communication distance. And NR Plus itself supports 16.7 million unique global networks and 256 overlapping networks. And of course, it meets this requirement of 1 million nodes in a single square kilometer. And then with regard to speed and latency, NR Plus enables data rates up to 3 megabits per second, which is quite high. And again, latency less than 1 millisecond on the packet level. You can also see latency under 4 millisecond end to end, which is also very low. And lastly, the network, it achieves packet reliability over 99.99%. And this is automatically handled in the lower layers. So application protocols don't really need to consider it. All this is handled by the standard itself.
So, Heidi, how does DECT NR Plus compare with cellular IoT?
Yeah, so I think with all new technologies, to fully understand their role, it's useful to put them in a context with other technologies. And cellular IoT is one that's very relevant here. So here we can see a graph mapping how NR Plus compares to other common technologies with specifically regard to range and speed. We can see cellular IoT technologies, they have a slightly lower data rate than NR Plus, but they outperform in regard to range. So one could say that NR Plus range can be classified as a neighborhood range. That's without a gateway, of course. And then cellular IoT can achieve national range, partly due to the fact that it uses this cellular infrastructure. So with regard to data rate, NR Plus can achieve, like I said, up to 3 megabit per second throughput. And cellular IoT has much lower than that, around 375 kilobit per second uplink for LTE-M and 60 for narrowband IoT. So in that regard, NR Plus kind of outperforms cellular IoT. So with regard to power consumption, which is also very relevant for IoT use cases, let's take a look at the different low power mechanisms that the different technologies employ. So with cellular IoT, you have something called power saving mode and extended DRX, which basically just allows the devices to go into deep sleep for a certain amount of time. And in theory, the devices can sleep for however long they want, really, or however long the user wants. With NR Plus, the devices can also sleep, but it's actually controlled by the relay nodes sends messages down to the leaf nodes, and it's controlled by the interval in which the relay nodes do that. And this interval can only range from 10 milliseconds to 32 seconds, so half a minute basically. So devices can't sleep for very long. So in that sense, cellular IoT lets the devices kind of save more on power consumption. With regard to gateway, cellular IoT does not require a gateway because each device has a SIM card and a subscription and connects directly to the internet, while NR Plus networks are essentially these private 5G mesh networks and require a gateway to connect the network to the internet. And then lastly, which of these requires subscription? So in cellular IoT, every device has to have a SIM card, whether it be an eSIM or a soft SIM, but they have to have a SIM and they are all required a subscription with a network operator to be able to connect to the cellular network. So this is a big plus for NR Plus because it does not require SIM cards or any payment to cellular carriers since it's non-cellular, and it doesn't rely on cellular infrastructure.
So, Heidi, what kind of applications is NR Plus a good fit for?
First of all, NR Plus is very good for any use case that requires a local private network, meaning there is no requirement for an external connection to the internet. That would be, for example, a factory or a warehouse that has a large amount of nodes where the information can just be transmitted locally, and you don't really require any gateway to connect to the rest of the internet. Smart city and smart metering are also good use cases where you have devices, say street lamps that are placed every tens to hundreds of meters. And then you can pick a select few that have gateway capabilities, whether it be Ethernet or, cellular, and then thereby sharing the cost of that. Another one is automation control. So NR Plus allows for the same reliability and latency as one would get with physical wires, but then without the physical constraints of wires. It's not necessary to have an immediate external internet connection because devices have local decision making. And the latency capabilities of NR Plus also make it suitable for professional audio applications with very low latency and relatively high throughput. And a benefit here is that NR Plus is compatible with legacy DECT solution. And there are actually a lot of legacy DECT solutions deployed today within professional audio.
Very cool. Now, comparing that to cellular IoT, what kind of applications would you recommend here?
So for cellular IoT, anything that requires high range, where the nodes are very far apart, so they need to be directly connected to the internet, they can't really be connected to each other. That would be, say, asset tracking on a national scale, for example, tracking vehicles or packages that are moving between cities, or use cases where the consumer would only buy a single device, so there's no other nodes to connect it to. So, say, pet tracking again, where consumers, usually buy one, or depending on how many pets they have, but where the nodes are far away or where there's a limited amount of nodes where you would want the devices to be directly connected to the internet. And then depending on what your needs are, the fact that cellular IoT uses cellular infrastructure can also be a benefit. So cellular IoT offers commercial network offering, meaning you don't need to maintain your own network because maintaining your network can be both a benefit and a drawback. So while NR Plus is good for dense mesh networks, cellular IoT is more suitable for use cases where the network is sparse and requires a wide area of coverage.
That makes sense. Now, can NR Plus and cellular IoT work together? And if so, what would that look like?
Yeah, definitely. NR Plus and cellular IoT can definitely work together. So using cellular IoT as the gateway technology to connect the NR Plus network to the internet is a very good use case. NR Plus enables you to set up a local private 5G mesh network, and then cellular IoT can then expand on this capability by connecting the NR Plus network to the rest of the internet. And cellular IoT means you're not relying on a wired connection. So, you pick out a few select syncs that can have a SIM card and access to the cellular network. And then you're also sharing in the cost of that subscription. So instead of one subscription per device, like you would see in a classic cellular IoT network, you would get one subscription per 10 devices, for example. So consider deploying NR Plus in streetlights across the city. Streetlights are usually placed at a consistent distance from each other, and this is in the range of NR Plus. And then you can pick select streetlights that have cellular capabilities as well and have connection to the cellular network. And in this scenario, the streetlights can serve as an NR Plus infrastructure for a wireless smart city. And then with that infrastructure in place, you can easily and with a very low cost add other kinds of NR Plus enabled devices to the network that wouldn't usually be able to perform like that.
That makes sense. Now, Heidi, what is Nordic doing in this arena?
For those that don't know, Nordic Semiconductor, we specialize in wireless technology for IoT. We have been established in cellular IoT for a while now with a device that's been out for around 5 years that supports both LTE-M and narrowband IoT. And that's our NRF91 series chipset. And we've also been a driver and a contributor to this new standard. We're a member of the DECT forum, which is the marketing group for the DECT technology. And our current strategy is to leverage our cellular investment. So our initial DECT NR Plus solution is being built around the NRF91 series, which is our existing cellular product.
Excellent. So, can we dig into the details of the NRF 91 solution?
Yeah, the NRF91 series is our chipset that's geared towards cellular IoT and now also DECT NR+. The NRF91 solution hosts an ARM Cortex M33 application processor. It has 1 megabyte of flash, 256 kilobytes of RAM, ARM Trust Zone, and it has an integrated modem as well as the PMIC, passives, and crystals, and also the RF front end. So essentially, the only thing you need to deploy your product is battery, some sensors, and then optionally a SIM card, depending on if you're using NR Plus or cellular IoT, and an antenna. And then, yeah, you're basically ready to go.
Excellent. Now, what are the benefits of the NRF91?
So, three main benefits I want to bring up. First of all, the NRF91 series provides very tight integration. Everything you need comes delivered in a small form factor SIP. The host MCU and the modem communicate in the SIP. The whole solution is developed by us, meaning support is very easy to get. And the SIP also comes fully certified as well. And this also leads to a smaller PCB and size costs. Secondly, it's very low power. Specifically for cellular IoT, our solution has the lowest power consumption of any similar device on the market. And this can optimize radio performance, and it also increases the battery life, meaning devices out in the field can last longer without having to change batteries. And then lastly, ease of use. With our solution, we offer a complete software development kit, the NRF Connect SDK. We also provide complementary tools, a lot of them specifically geared towards cellular. And our solution is, like I said, globally certified, which then can result in a faster time to market.
Cool. Now, can we talk a bit more about the variants of the NRF91?
So we have three variants based on the NRF91 series. First up is the NRF9160 System in Package. This is our current cellular IoT solution. It supports both LTE-M and narrowband IoT. That's the two low-power cellular technologies that's geared towards the IoT use case. This product has been out for around 5 years. Like I said, it is widely available today, and it's also been deployed in a range of products. And yeah, like I said, it has a multi-mode LTE-M and narrowband IoT with GNSS modem. And then we have the NRF9131 mini SIP and the NRF9161 SIP, which has been announced and will be available in Q4 and Q1 next year, respectively. So the NRF9161 SIP is very similar to the NRF9160 SIP, but with full support for LTE-M and narrowband IoT, in this case, 3GPP release 14, while the NRF9160 supports 3GPP release 13, which is the previous release. So a few more features with regard to cellular IoT in this area. And in addition, this SIP will have support for a DECT NR Plus modem. So this is our new DECT NR Plus solution. And then we have the NRF9131, which is a smaller version of the 9161, where we have taken out the PMIC and the passives and crystals for a 50% size and 25% height reduction. But it's feature and software compatible with the NRF9161. So you can develop on the 61 and then switch 31 later on during deployment or production phase. And then when it comes to the DECT NR Plus solution, Nordic provides the physical layer implementation as a firmware. So that's the bottom layer of the protocol stack. And then our solution partner, WirePass, they provide the full mesh stack solution to run on top of the Nordic provided firmware. And they'll also provide the SDK for DECT NR Plus as well.
Fantastic. Now, Heidi, if my audience wants more information about this topic, what kind of support does Nordic offer?
Yeah, so we offer a wide range of development tools and platforms to help our customers with their development. Two specific ones I want to bring out is the Nordic Developer Academy, or Dev Academy, has interactive courses on different topics with theory and coding exercises to kind of teach you how to develop on Nordic hardware. So the Cellular IoT Fundamentals course, if you're interested in the NRF91 series, it teaches you how to get started with the NRF91 series hardware. It teaches you how to get connected to the cellular network, how to get a GPS fix, and it has a few quizzes you have to take, and then at the end, you can get a nice little certificate to post on LinkedIn. We also have a course for how to use our SDK, the NRF Connect SDK, which is very useful. And then the other thing is the developer zone, the dev zone, where we have a whole team of qualified engineers in our technical support team that are ready to answer any questions you submit. We also have the Dev Zone blog, which has technical blogs about a wide range of topics. One of the most recent ones is called DECT NR Plus, a technical dive into non-cellular 5G, which goes into a bit more detail about the DECT NR Plus technology specifically. We also have a webinar platform with on-demand webinars that you can watch anytime. And there are two there specifically about DECT NR Plus, understanding DECT NR Plus and an introduction to DECT NR Plus. So those are definitely worth checking out. And in addition, the DECT Forum is hosting a webinar series this year. And the next one is the third one in the series, which will be held after the summer. So you can follow that as well for more information. Yeah, so I hope people learned a bit about non-cellular 5G or DECT NR Plus.
Fantastic. Well, Heidi, I think that's all I have time for today. Thank you so much for joining me.
Thank you so much.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Nordic Semiconductor. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talks section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/